So we're going to look at solving certain shapes of algebra, of equations today, because they will help you with the trigonometry. But I want to just remind you of some basic algebra skills, so that when we're applying them to the new trigonometry stuff, you can tell apart the knowledge you should already have from before and the new knowledge. So I've got a formula of this shape, where a squared is b divided by c, and we're going to use these inputs to solve for a, just to remind you how that algebra works. So with a formula, we just read left to right, substituting anything we know for a number, anything we don't know we'll leave the same. So this reads left to right, it has a squared equals b, which we know is 8, divided by c rather, which we know is 10. Now that fraction could be simplified if you wanted to, or you could turn it to a decimal very easily. But we don't need to, because we don't actually care yet. That's not the answer to the question. So as with all algebra, you have a choice of when to make things simpler and when just to leave them and not think about them. So what you need to recognise is that 8/10 is a number. That's all you need to know. You don't really care what it is at this stage because it's not a. We want a. This is a squared. So, some algebra now. How do we get from a squared back to a? Well, we have to square root. So a is the square root of 8/10, which your calculator can now do. So now that we have an explicit expression for a, you can put it through a calculator in one go. Square root of 8/10. And that gets you some surd, which you can then simplify by using the SD button, and it comes out as 0.89-ish. So the key thing there is that I want you to think about what the relationship is between the square root and the squared. One way of phrasing this is to unsquare a. That's not the normal way of phrasing it, but it's what's going on here. The square root is the unsquaring of something. And that is how algebra works. We undo stuff. So we look at this second arrangement, we've got a slightly different layout where we know what a is. So this says 3 squared is b over 4. Again, you could work out what 3 squared is if you wanted to, and if it's easy you might, and if it's tricky you probably don't need to. But what we want to get at is b. What's being done to b? Well, it's being divided by 4. How do I solve that? I times by 4. So I get 4 times 3 squared is b. And at this point, pull out a calculator or do it in your head. What is 4 times 3 squared? I think it's 36. And again, I want you to think about why we multiplied by 4. It's because it's undividing by 4. 2 more to go of some fairly simple algebra just to get into this idea that some functions don't need to be interpreted very much. So here we've got some much larger numbers, and that isn't very clear, so that's the cube root of a. So the cube root of a is 340 184ths. And now you start to see a situation where cancelling the fraction is tricky, so it is extra effort to go through. Whereas 8/10 was easy to simplify, this is not easy to simplify in your head. So it really does have a benefit of just not bothering until you need to. So to get a by itself, we've got to think about what's being done to a. It's being cube rooted. How do I uncube root? Well, that's cubing. So a is 340 184ths cubed. And it's cubing everything. The bracket is quite useful there, it'll help you out. But this function here is undoing that function. So bracket fraction 340 184 close bracket cubed, oh not 9, close bracket cubed, and it gives out a decimal which is roughly 6.31. I didn't need to work out what that fraction simplified to. I didn't need to cube these things. That's what the calculator's for. I had to know the algebra to get the right process at the end. And finally, we are asked to work out c when we're told what a and b are. So the cube root of 45 is 100 over c. Again, this happens to be a number that you could work out if you could be bothered, but there's no point because we're going to do some algebra to it anyway. So to get this c by itself is actually quite fiddly. At the moment we're dividing by c, which means we've got to do something to make it not being dividing anymore. So the simplest thing is times by c. So we get c lots of the cube root of 45, which again is just some number. Who really cares what it is at this stage? And then to get c by itself, well, we have to undo this timesing. So C is 100 divided by the cube root of 45. Now that might look horrible, but I want to remind you that it's just some very simple algebra. We divided by a thing, we divided by a number. The number looks complicated because it has 4 symbols, 4 characters involved in getting it to come there, but it is just dividing by a number. So again, get the calculator out, 100 divided by cube root of 45, and you can just type it in directly as it looks, and that's an important feature as well about how this algebra works. And apparently that is 28.11-ish. Who knew or cared? My point here is that no matter how complicated these things get, these functions here, they still just behave like numbers. You can divide by this thing. You can multiply by the same thing if you need to. It's only when you want to get what's inside the function that you need to think about undoing the function. So if you care about what's actually being cube rooted, you need to peel the cube root off somehow, and it's going to be cubing in this case. Here, if we cared about what was actually in the squaring, we have to peel off the square somehow, and that's done by square rooting, by undoing what's there. But sometimes you don't need to bother. I left this as 3 squared all the way through, because I didn't need to work out what it was, it didn't help. And that's an important concept for how some of the trigonometry works we're doing this week. So hopefully that'll sit there, and you can do some of that yourself. And I'll see you with the next bit.